tell you something about the Schwarzschild-Radius today. It's one of my favorite astrophysical topics. In general relativity, gravity is understood as the curvature of space-time caused by mass and energy. To describe the space-time around a static and spherically symmetric object, something that does not rotate and does not change with time, we solve Einstein's field equations in the vacuum region outside the mass. To do this, we begin by assuming the most general possible form of a space-time that is static and spherically symmetric. This form contains two unknown functions that depend only on the distance from the center. When we insert this general form into Einstein's field equations and solve them, these two functions become fully determined. The result is what we call the Schwarzschild solution. This solution describes how time passes and how distances behave in the curved space-time around a spherical mass. An important feature appears when we examine the component of the metric that represents the flow of time. As we move closer to the central mass, this component decreases. At a certain specific radius, it goes all the way to zero. At the same radius, the component of the metric describing radial distances grows without bound. This combination signals that, at least in the coordinates we are using, we cannot extend the description smoothly past that surface. This critical radius is what we call the Schwarzschild-Radius. It represents the location of the event horizon of a non-rotating black hole. At this boundary, the structure of space-time becomes so strongly curved that no path leads outward to the rest of the universe. Nothing inside this radius can escape, not even light. It is important to understand that the strange behavior of the metric at this radius is a coordinate effect. The coordinates themselves become ill-behaved there. The true physical singularity lies at the center, where the curvature of space-time becomes infinite. The Schwarzschild radius, in contrast, marks the boundary of the region from which escape is impossible. So in summary, the Schwarzschild radius arises naturally when we solve Einstein's equations under the assumptions of spherical symmetry and no rotation. It marks the surface where the flow of time, as measured from far away, effectively stops, and where the geometry of space-time prevents anything from escaping outward.